In this video, I'll be discussing how to do data exploration and data visualization with box plots. So data visualization is key to data analysis and presentation. In a previous video, I discussed how to make and interpret histograms. Now, a similar data analysis tool are box plots. Box plots and histograms kind of get at the same point of showing the distribution of data. Histograms are useful when you have one single group or maybe two groups that you're interested in, like male versus female. Once you start having multiple groups, box plots start becoming more useful. And often, even if you have two groups, a box plot serves a pretty good purpose. So now I'll talk about how box plots are used and how they're interpreted. So the x-axis of a box plot are categories or groups. So in this case, I've taken Galton's data on human height, and I found all the families that had one child, and I had all the families that had 6 or more children, and I wanted to compare whether the height of children, the distribution of heights of the children depended on the number of children that were in the family. So the x-axis are different groups, categorical variables. The y-axis is the numeric variable, the quantitative variable that we are interested in. In this case, it is the height of the offspring. The thick bar here is the median. So in Galton's data, families that had 6 or more children, the median is about 66 inches. Whereas it is higher in families with one child, it is closer to 73 inches. But often when we look at data, and the reason why we do data analysis with box plots and histograms is we're interested not just in the mean or the median, but we're interested in the whole distribution of the data. So the box plot summarizes all of that information very efficiently. So we can go beyond just looking at the median, which is the 50th percentile, and we can look at the range and the other percentiles. So these bars here, these are sometimes called whiskers, these upper bars and lower bars. These represent the maximum and the minimum values of the data. Sometimes there will be outliers, and different computer programs will treat outliers differently. But when you see little dots up here and then a bar below them, when the whisker is below the bar, that means the computer is doing something internally to treat outliers a little bit different, or rather extreme observations a little different. In that case, we should probably call instead of the maximum minimum, we should say the trimmed maximum. This is a maximum value where the outliers have been trimmed off. So this top of this is the maximum ignoring these extreme observations. So the overall range is just the distance between the max and the minimum, or if you have outliers, it's a trimmed range, to be more specifically, from the maximum to the minimum. So we can look at our boxes and we can compare the range. So whereas the median is higher here in the one-child family, the range is also higher. That means there's more variability overall. The boxes then represent specific percentiles. The median to the 75th percentile is between the central line and this first box. And that means that 25% of the observations, the 25% that are above, right above the median, are contained within that box. So a large chunk, 25% of the data, has values between the median and that bar there. The 25th percentile is from the median down to this box. So we can say here that the median is from maybe 73 to just above 70. And you can actually see here that the median, the 25th percentile, is smaller. The data are more compressed. There are fewer data points there's not fewer data points, but the data points are more close together in the 6 or more children data set. The upper quartile is represented by this upper whisker, so 25% of the data is represented by here. So there's a much larger space here. This means that the data kind of tails off from the 75th percentile on up. The lower quartile is from the bottom of the box to the bottom of this whisker here. So we have upper quartile, lower quartile, 75th percentile, 25th percentile. Again, each one of these groupings represents 25% of the data. So the length of this whisker here represents 25% of the data. The length of this whisker, 25% of the data are there, and so forth for each one of the boxes. So overall, that means in this main box here, there's 50% of the data. 50% of the data points have values between this bar and that bar. So even though the relative size of these two boxes are different between the one child and the 6+ child group, the overall width of the box here is about the same. So it indicates that aspect of the distribution, most of the data in both of these groups is clumped around the median. Though here, this bar extends far from the median, so that means there's there are some individuals that are much higher than the median in this group, whereas here, this bar is very small. This means there really aren't that many individuals that are spread far away from the median. So one thing you can think about as a parting challenge when you look at histograms, when you look at box plots, can you think about how the histogram of these data might compare? Taking what you know about the quartiles and the median, can you sketch on a piece of paper what the relevant box plot and histogram would be? One thing to note is these bars represent the upper 25% of the data. These are not error bars, and that's a common mistake that gets made. These are not error bars. We'll talk about error bars in a subsequent lecture.